Hello my dear students, welcome to Deeksha Karnataka YouTube channel, and today I am going to discuss a chapter which is there in your FA2 exam. And what I am going to discuss, I am going to discuss all the important MCQs from this chapter. But before I begin, I just wanted to tell you that what are all the type of questions that you are going to get from this chapter. Now, ray optics and optical instrument is one of the most important chapter, and in this chapter you will get not only one but two questions as objective. Okay, so ray optics and optical instrument, total marks allotted in this chapter is 10, and you will get two objective type questions. Most probably one of them will be MCQ, another will be a fill in the blanks. Okay, now exact breakup is not available. We can see that 1, 2, 3, 4, 5, 6 chapters actually noted for two questions. So one chapter will have both of them should be MCQ from one of the chapters, but that clarity is not given in this blueprint. But as far as we concerned, we should know that one MCQ and one fill in the blanks will come, and there will be one 3 marker question and one 1 marker question. So this is the chapter blueprint for ray optics. So total 10 marks is reserved for this chapter, and if you can answer, Nagraj is saying hi. Nagraj, how are you? Welcome to channel. So you are the first one to comment. Well, congratulations. Now let us start with the questions. Okay, so we will start with the questions. Okay, so control, let's start. Let me zoom it in and make it full screen. Yes, I hope you can see. First few questions will be easy as usual, and this is your blueprint taken from your question bank. This question is taken from your question bank, right? Let's start. First question: in reflection of light, the angle of reflection is more than incident angle, less than incident angle, equal to angle of incidence, more than incident angle. Easy question. Yes, option C. I will not discuss any time on this question. Second question: focal length of a spherical mirror depends on what are all the factors? So object distance, image distance, both object distance and image distance, radius of curvature. Very interesting. This question is much more interesting than the previous one. So let's see who can answer this question. Right, Nagaraj is saying 2A. So focal length of a spherical mirror, object distance. So two equations might come into your head. First of all, 1 by U plus 1 by V equals to 1 by F. But this is mirror equation. This does not give you the focal length. Focal length is independent of U and V. Okay, focal length, in fact, for lens or mirrors, it does not matter. Focal length is always independent of U and V. Okay, U and V together, they are dependent on F. How can F be dependent on U and V? Right? So F is given by R by 2 for a spherical mirror, and for lenses we have lens maker's equation. Okay, so both focal lengths are actually dependent on radius of curvature. It does not depend on object distance or image distance or both. So this is a very trick question. Many students will answer this, but actually it is radius of curvature if you remember this expression. So treasure money hunt answered this correctly. Nagaraj, okay, Nagaraj, after understanding, he changed his answer and saying now it is option D. Yes, correct. Now answer the question number 3. when an object is placed at infinity from a spherical mirror, the image is formed at infinity, principal focus, at center of curvature, at the pole. Okay, easy question. Let's see. Tanmay Shetty is saying option B, principal focus. Yes, when the object is at infinity, all the rays either go directly meet at focus or they appear to come from focus. So image is basically formed at focus. It can be real, it can be virtual, based on the mirror or the lens. It does not matter. For mirrors as well as lenses, image will always be formed at focus. It can be real, it can be virtual, based on the device you are using. Okay, next question. The focal length of a spherical mirror is equal to its radius of curvature, 2 times the radius of curvature, half of the radius of curvature, does not depend on radius of curvature. This is another easy question. So if you are following previous question, you should be able to answer. Nagaraj answered 3B, now answered 4C. Tanmay Shetty, Rakesh also answered C, 4C. Let's see. So here one twist is there. So they have a printing mistake over here. Both options they have marked as C, but we know I will not cheat. I will give you this as option D. Okay, so they have given both options as C. It is not me, it was directly published by the board. Okay, obviously option C is correct answer. The true option C is the correct answer, not the fake answer option C. Okay, now for reflection in spherical mirrors, all distances are measured from the dash pole, principal focus, center of curvature, from object. Let's see. For reflection of spherical mirror, all the distances are measured from Nagaraj and Tanmay Shetty. Both are saying pole. Yes, pole is the point from where we measure the distances. In refraction of light, now from reflection slowly we came to refraction. Sin I by sin R equals to 1, I by R equals to constant, sin I into sin R is constant, or sin I by sin R is constant. Yes, Nagaraj, Tanmay, Treasure Money, both all of you are correct. Sin I by sin R is constant, and that is known as Snell's law. Right? Now they directly came to total internal reflection. For total internal reflection of light, light should be traveling from rarer medium to denser medium. Light should be traveling from denser medium to rarer medium. Light should be incident along the normal. The angle of incidence should be equals to 90 degrees. Let's see. Nagaraj saying 7B, Tanmay Shetty saying B, Rakesh and Ashel D'Souza, all of you are saying option B. So option B must be the correct answer, right? Yes, light should be traveling from denser to rarer. Option B is definitely the correct answer. Congratulations. Next question. For 1 crore rupees, an object of finite height is placed in front of concave mirror within its focus. It forms real enlarged image, real diminished image, virtual enlarged image, virtual diminished image. So what is the condition? Object of finite height is placed in front of a concave mirror. Again they are going back to concave mirror. Within its focus. Within its focus means, suppose this is the pole, okay, and this is the focus. Within its focus means between pole and focus. The language should be more clear. So they should mention that it should be between pole and focus, and mirror is a concave mirror. So what will be the type of the image formed? So Achin Kushal is saying option B. Now option B for the last question is correct. Question number 8 we are discussing. Let's see what is the question. Concave mirror placed in front of focus. So what should be the answer? Answer it quickly. I am waiting for your answer. Anyone? Anyone? Tanmay Shetty is saying option C, that is virtual and enlarged. So for a concave mirror can form both type of images. It can form real image, it can form virtual image. So if it is beyond the focus, if the object is beyond the focus, we get real images, no matter where the object is, if it is beyond focus. If the object is exactly at focus, image goes to infinity. Okay, if it is within the focus, that is closer, less than the focal length, it will give you a virtual image on the same side of the mirror. So basically you will get a virtual and enlarged image. It is similar to that of a convex lens, giving you a feel of a spyglass, right? If you're watching something using a convex lens, we used to have a convex lens coming in our geometry box when I was a kid, only to see if the points are perfectly drawn or not, and we used to play with spy with using that convex lens. Okay, so basically it's virtual and enlarged image. Yes, correct answer. Tanmay answered first, then Nagraj. Tanmay also answered 9th question. The speed of light in a medium depends on angle of incidence, angle of refraction, refractive index, its mass density. Now this is definitely not correct. Okay, mass density has nothing to do with speed of light. Okay, even though it appears very catchy, because mass density should higher the mass density should speed be smaller. No, it does not depend on mass density. Optical density, you can say optical density, and optical density is given by refractive index. Refractive index is also known as optical density. Okay, that's why this is separate than mass density. So speed of light depends on refractive index. In fact, speed of we know that refractive index is speed of light in vacuum divided by speed of light in that particular medium. So based on the speed of light, refractive index changes, and based on refractive index, speed of light changes. Now next question, speed refractive index of a medium. Now it is a reverse question. Refractive index of a medium depends on thickness of the medium, angle of incidence, mass density of the medium, optical properties of the medium. Easy question. Nagraj also answered 9C. Harsh J. Kamble also answered 9C. Okay, Harsh J. Kamble is saying option 10C. Mass density of medium. Refractive index, I just wrote the equation, Harsh, n equals to C by V. So it does not depend on mass density. Thickness of the medium obviously does not depend. Okay, refractive index of a material is constant. It does not change with the thickness, right? Angle of incidence is also immaterial. Only thing that can change refractive index is the optical properties. Okay, optical properties, how it is allowing a light to pass through it. Okay, so it depends on optical properties. Okay, and in the reverse sense of the previous question, you can say that refractive index depends on the speed of light in that particular medium, and speed of light changes basically because of the optical properties. Correct answer will be 10D. Komal Kaushik came, welcome Komal after a long time. Nagraj is saying 10D. Komal also went to question number 11. Tanmay saying 11B, 11B, 11B. Okay, 11, let me check the question number 11. When a light ray travels from rarer medium to denser medium, its speed increases, decreases, wavelength increases, frequency decreases. Let's see. Now remember that frequency of a light is constant. Does not matter on which medium it is. Frequency of light is a constant. It defines the ray. Okay, so for example, gamma rays frequency is 10 to the power something 12. So that defines the gamma ray. Wavelength can change, speed can change, but frequency does not change. When a light ray travels from rarer to denser, speed decreases, okay, wavelength also decreases. Speed and wavelength both decreases, but here they have given wavelength increases. This is not correct. So when the light is traveling from rarer to denser, speed decreases. Speed decreases is correct. So 11B is correct, not 11C. Yes, most of you have answered 11B only. In fact, everyone answered 11B. Komal, Tanmay, Meenakshi, Subbu Yadav. Sir, for us exams are going on, so couldn't attend live. Okay, Komal, no problem. So that's why I have chosen one chapter which is actually there in your midterm exam, right? FA2 exam. So we will try to close it as quickly as possible so that you should be able to get some, if some question is coming from your question bank, MCQs you should be able to answer, right? Snell's law fails in the case of, this is a very interesting question, light traveling from denser to rarer, oblique incidence. When light wheeling traveling from rarer to denser, normal incidence. Let's see. Yes, Tanmay Shetty, Nagraj, Komal, Subbu, Meenakshi. Meenakshi, no, 12B is not correct. It will be 12D. Normal incidence. What is the meaning of normal incidence? When light ray is falling normally. So in that case, what is the angle of incidence? Angle of incidence is measured with respect to the normal. So normal is also along this line. So two lines are along the same line. What is the angle between them? Angle must be equals to 0. If I is 0, then light is traveling in this direction. R is also 0. So sin I by sin R is constant. That is no longer valid because it is 0 by 0 condition. Okay. So L'Hospital rule, you might L'Hospital rule. Okay, we used to say L hospital or L'Hospital rule you have to apply and do it, but it is not a limit. So L'Hospital rule can not be applied. So this is a particular case where you cannot apply Snell's law because I and R both are 0. The principle of optical fibers is reflection of light, refraction of light, dispersion of light, total internal reflection of light. Yes, 13D, everyone answered. So total internal reflection, optical fibers are the application of total internal reflection. The focal length of a lens is depends on the this English wise this is incorrect. Focal length of a lens depends on itself is correct. There is no need for is. Refractive index of the material, radii of curvature of two surfaces, diameter of the aperture. Only option 1 is correct. Both option 1 and 2 are correct. Only 2 and 3 are correct. Option 1, 2, 3 are correct. So focal length of a lens. Let's see who can answer this. Refractive index, radii of curvature, diameter of the aperture. Komal Kaushik is saying 14B. Yes. So focal length of a lens is given by lens maker's equation. It says that n minus 1, 1 by R1 minus 1 by R2. So if you see that in this equation we have refractive index, that is n, and we also have radii of curvature. Radii of curvature means radii is plural of radius. Here we have two curved surfaces, that's why radii. Okay, radii of curvature, that means R1 and R2, but diameter of the aperture does not come over here. Okay, how big the lens is or how small the lens is, that is not there in the focal length calculation. So this is independent. So focal length is independent of diameter of the aperture. Okay, so only option 2 and 3 are correct. Two thin lenses of focal lengths F1 and F2 are in contact. The power of the combination is A. This one, B this one, C this one, D that one. Okay. Two thin lenses of focal lengths F1 and F2 are in contact. The power of the combination. The power of the combination is given by Harsha J. Kamble. Okay, sorry, I spoke your name as Harsh. Harsha is saying 15B. Nagaraj is saying 15B. Komal Kaushik is also saying 15B. So power is basically given by, let's see, power is given by 1 by f. Okay, this is the power, and that is given by 1 by f1 plus 1 by f2. So that is f1 plus f2 divided by f1 f2. So this is directly the power. If they ask you focal length, then it will be f1 f2 by f1 plus f2, but because they asked you directly the power, that means option B is correct, not option C. Yes, most of you. Hi Rukmini, how are you? Nagaraj is answering option 16, question number 16. Let me check the question number 16. You guys are doing so fast today. I'm really happy. The angle of minimum deviation of a prism is dependent on only angle of the prism, only refractive index of the prism, angle of incidence, both angle of the prism and refractive index. Easy question. Angle of minimum deviation, that is delta m. Okay, it depends on what? 16D. Komal Kaushik and Nagaraj, all of you. Subbu Yadav, 15B. Yes, correct, Subbu. You are answered slightly late, but yes, correct. Good job. So next, it will be 16D. Both angle of the prism and refractive index, because refractive index of the prism material is given by sine A plus delta m by 2 divided by sine A by 2. So from here you can calculate delta m. So you need to know the refractive index, you need to know the angle of the prism, then only you can calculate delta m. So it depends both angle of the prism and refractive index. Question number 17. A ray of light is incident on a glass air interface at an angle greater than the critical angle for the pair of the media. Then the ray undergoes refraction only, partial reflection and partial refraction, total internal reflection, grazes the surface at the interface of the two media. Sir, we need numericals on ray optics. Meenakshi, you can check my FA2 lecture. Okay, there I have solved numericals on ray optics, also ray optics Brahmastra, which is based on your previous year papers, based on your model question bank. Every important questions from previous year paper as well as question bank are covered there, so you can check that out in Brahmastra. If you go towards the end of the lecture, I have solved the numericals, important numericals from ray optics chapter. Okay, so that is also done. Ray optics was done, I think, 1 or 2 weeks back. So not now, it was done long back. Wave optics is also done. And or you can check the FA2 lecture where I have specifically solved some numericals for your FA2 exam. That is, there also I have solved numericals. Right? A ray of light incident on glass air interface at an angle greater than the critical angle for the media. That means I is greater than theta c, so it should go total internal reflection. The light should go total internal reflection. 17C. Sagar, hi Sagar, you are also late today. 17C is correct. Rukmini, Nagaraj, Komal, everyone answered. Now let me check the 18. The magnification of a refracting telescope. Magnification of a refracting telescope is 18A. Sagar is saying 18C. Sagar, why 18C? Why 18C? This is length of the telescope. FO plus FE is length of the telescope, and FO by FE is the magnification. FO by FE is the magnification, okay, and FO plus FE is the length of the telescope, not magnification. Okay, don't be confused. Now question number 19. A lens of large focal length and large aperture is best suited as objective of an astronomical telescope, since a large aperture contributes towards the quality and visibility of the images. A large area of the objective ensures better light gathering power. A large aperture provides a better resolution. Only 1 and 2, only 1 and 3, only 1 and 3, 1, 2 and 3. Let's see. Even though resolution is not part of the syllabus, you should be able to answer. A large aperture contributes towards the quality and visibility of the image. A large area of the objective ensures a better light gathering power. This is about telescope. Pradeep Rathod is saying option D, Rukmini is saying 19D, Sagar Anmol Chopra is saying D, Nagaraj is also saying option D. Now here the resolution basically depends on 1.22 divided by lambda. This is called resolving power, or okay, sorry, resolution and resolving power I am getting confused. Okay, it is okay. You can consider it to be a resolution. So resolution wise it is okay. So yes, both 1, 2, 3 and 1, 2 and 3 can be considered. So more bigger is the lens, it gives you a more amount of light it can capture, and more light it can capture, you get a better image, and visibility of the image is better. The resolution of the image is also better. Now convex, now these questions are slightly tricky, hot questions, so be prepared. Statement number 1, convex mirror is preferred over a plane mirror in vehicles to observe traffic coming from behind. Convex mirror is preferred over a plane mirror in vehicles to observe traffic coming from behind. So it is a rear view mirror. Rear view mirrors, we generally use convex mirrors. Now statement 2, convex mirrors have large field of view and images of real objects formed by convex mirrors are correct. Images of real objects formed by the convex mirror are erect, sorry, not correct, erect. Okay, so statement 1 and 2 both are correct, but statement 2 is not a correct explanation for statement 1. Statement 1 and 2 both are correct, and statement 2 is the correct explanation for statement 1. Statement 1 is correct, statement 2 is wrong, 1 is wrong, 2 is correct. Sir, how to prepare for second quarterly? Sagar, second quarterly means FA2, right? FA2 exam, I have made 2 videos where I have made one important chapters, and they are all important questions. Means all the chapters that is going to come in your FA2, and all the questions that might come from that chapter, important questions. Also I have given the solution along with MCQs, numerical questions. Don't forget to check that out. Okay, if you study that, if you have any other chapter in your syllabus, don't forget to mention that in that video. I will try to at least make important questions from those chapters. Okay, there will be one more video coming this weekend. Some students already posted questions, posted that, sir, I do not have other 2 chapters. 2 chapters are there, 2 chapters are not there. So I will add some questions, and I will give you a video on all the important questions, the chapters that you have in your syllabus. Okay, so don't forget to check that out. That will be very, very essential for all of you. Don't worry, don't get fearful. Okay, I am here, I will try to help you as much as possible. So statement 1 and 2 both are correct, and obviously because it has a large field of view and it produces an erect image, that gives us the correct idea that how many vehicles are there. So larger field of view means you can see a lot of area behind you. Okay, if you are using plane mirrors, only you can see up to a certain distance, you will not be able to see large area behind you. That's why convex mirrors are used, and this is the correct reason for convex mirror being used rather than a plane mirror. Another statement based question. The images formed by a total internal reflection are much brighter than those formed by mirrors or lenses. Statement 2, in total internal reflection, the light is completely reflected and there is no loss of intensity of light. Now answer this question. How to prepare for second quarterly all subjects? So all subjects will give you videos, okay, 1 hour, 2 hour video. If you prepare that just before exam, you should be able to do fine, just fine. Also the PDFs of those lectures are also available in our WhatsApp channel. I think link was shared yesterday or day before yesterday. Go check that out, download the PDF, study from there, you should be fine. All subjects, I think chemistry is not yet uploaded, maths was done, biology was done, Kannada and English, and we could not do this time, but we will promise that we will try to do for your board exam and pre-board exam, definitely. Okay, Kannada and English, that is in our priority list, and computer science as well, but we will do that before your pre-board. Next, this question, who will answer this? 21A. Komal is saying 21A. Why 21A? Okay, sorry. Statement 1 and 2 both are correct, and statement 2 is correct explanation. So they have changed the order. So that's why be careful, read the options. Generally this comes option A, but in first question they have given not a correct explanation in option A, and correct explanation is given in option B. In NEET or in competitive exam, generally this statement, this is the correct order. Now again 22, statement based question. The focal length of equiconvex lens of refractive index 1.5 placed in air is equal to radius of curvature of either face. So let me understand. The focal length of equiconvex lens of refractive index 1.5 placed in air is equal to radius of curvature of either face. For equiconvex lens, radius of curvature of both faces is same. Okay, so here 1 upon f equals to 1.5 minus 1 into 2 by r. Why so? Because of the second condition. Equiconvex lens means both sides have same radius of curvature. So here we will get 0.5 into 2 divided by r, or 1 by r, or f equals to r. So first statement is correct, second statement is also correct, and because both sides have same radius of curvature, you are getting this 2 by r. So both 1 and 2 are correct, and statement 2 is correct explanation. So option B for 22, option B is correct. Yes, B, know your nation. Option B is correct. Nagaraj also saying option B. Komal, no, option 22A is not correct, 22B is correct. Both are correct, and this is because of this we are getting F equals to R. If you put the lens maker's equation, only because R1 is equals to R2 and 1 is negative, 1 is positive, you are getting 2 by R. Okay, that is the reason, that's why we are getting F is equals to R for a equiconvex lens of refractive index 1.5. Okay, so correct answer was option B. Now 23. So check the options. For sometimes they change the order of A and B. If a glass prism is immersed in water, its angle of minimum deviation is increases. Angle of minimum deviation of a prism is increases with increase in the refractive index of the prism. Very interesting question. Let's see who can answer this. 23. Man of the match. Whoever can answer will be man of the match. Rukmini is saying man of the match or woman of the match. Both is possible. Saying option 1 is wrong, option 2 is correct. Someone else is saying 23B. B. Let's see. So we know that. By the way, Rukmini is correct. Else whoever is saying B and C, they are wrong. Okay, N is given by sine A plus delta by 2 by sine A by 2. Okay, so here we can see that what we can see is this delta has a direct relationship with refractive index. Okay, because you can take the sine inverse and you will find some relation of delta with respect to this refractive index. So in other words, we can say that delta M is directly proportional to refractive index. The constant of proportionality is not simple, but you can say that delta m is directly proportional to refractive index. That means if refractive index increases, then delta will also increase. If refractive index increases, then the delta will also increase, right? And this is only possible because of the sine angle. If it is a cross angle, it is not so simple, because cos does not increase, cos can decrease, right? Cos starts with 1, goes to 0. Only sine starts from 0, goes to higher value as the angle increases. So that's why we can say that if delta increases and n increases, delta will also increase. Now, what about the refractive index when you put the glass into water? When you put the glass into water, what is the relative refractive index? Relative refractive index is Ng by Nw, right? Relative refractive index is refractive index of the glass divided by refractive index of the water, right? That means that overall refractive index actually reduces. Overall refractive index actually reduces. So if refractive index reduces, delta will also reduce, it will not increase. So if a glass prism is immersed in water, because refractive index is reducing, the minimum deviation will also reduce, because there is a direct proportionality relation. Okay, so second statement is correct. Angle of minimum deviation prism is increases with increase in refractive index. Okay, so delta increases with increase in A, but in the case number 1, refractive index is decreasing. Because refractive index decreasing, then angle of deviation will also decrease. So statement 2 is correct, statement 1 is wrong. So option D is correct, not option B. Okay, okay Nagaraj sir, explain again please. So which part you want to explain? This one? This one? Okay, so this formula you know, right? This formula you know, right? Now, and this one is also very clear, this part also very clear. Only thing that you might have a problem is with this, right? Sine A by 2. So what we can do, this entire part we can take here sine, see if I am writing it correct or wrong, sine A plus delta m by 2 equals to n into sine A by 2, right? Or you take sine inverse on both sides and you get A plus delta m by 2 equals to sine inverse of this entire thing, n into sine A by 2. Or you can write that delta, I do not have enough space over here. So we can write it from here that delta m is sine inverse of this term, okay, minus A, and then we can multiply with 2. Okay, so this is the part of delta m. So delta m is related to this n, right? So we can say from this equation actually sine inverse can be extended as a expansion. If you have done binomial expansion, similarly that sine inverse can also be expanded, and you can eventually find the relation that delta m is directly proportional to n. Not the relationship is not very simple, not super easy, but delta m is directly proportional to n. So that means if n increases, Suppose the refractive index increases from 1.5 to 1.6, then delta's value will also increase from say 30 degree to 35 degree. Okay, so the angle of minimum deviation depends on refractive index. Okay, so angle of minimum deviation depends on refractive index. So if refractive index increases, delta will also increase. Okay, so second statement in this particular question is correct. Angle of minimum deviation of a prism increases with increase in the refractive index of the prism. But if you look into the first statement is talking about glass prism is immersed in water. So whenever you are taking a material and if you put it inside another material, okay, the refractive index will always decrease unless and until you are taking air. Even if you are taking air and you are putting in water also, the relative refractive index will decrease if it will be less than 1. So remember that whenever you are taking one material other than air, if you immerse it in any other liquid or fluid, okay, or gas, then the refractive index will always decrease. This is called relative refractive index, right? So relative refractive index is always less than the original refractive index. So because refractive index is decreasing, that means delta has to decrease but not increase, right, Sagar? I hope the doubt is clear. So option D is correct in this case. Now 24, we have two more questions, so quickly simplify them. In a simple microscope, the object is placed at a distance slightly less than the focal length of the objective lens. When the object is placed within the focal length of a convex lens, an enlarged erect image is formed. In a simple microscope, the object is placed at a distance slightly less than the focal length of the object. So simple microscope is basically a convex lens, okay, and this is the focal length, and the object is placed slightly less than the focal length of the lens. And second statement says that when the object is placed within the focal point of the convex lens, an enlarged erect image is formed. An enlarged erect image is formed. So statement 1 and 2 both are correct, but statement 2 is not correct explanation. Statement 1 and 2 both are correct, and statement 2 is correct explanation. 1 is wrong, 2 is correct. 1 is correct, 2 is wrong, 2 is wrong, 1 is correct. Yes. Komal Kaushik is saying, what about model question papers? Model question paper 1 already published. Model question paper 2 and 3 will be published very, very soon. Don't worry. We are currently holding on because in FA2 the chapters are slightly different. In model question paper you have all the chapters, but definitely we will bring out model paper 2 and 3 very, very soon. Once your FA2 is over, we will bring out all other 2 papers as well. Paper 1 is already published. If you have not watched, you can go to our channel. Physics, chemistry, maths and biology, all 4 subjects are done. Okay, so here in this particular case, simple microscope is basically works because if it is kept at a distance less than focal length, you get a magnified enlarged virtual image, and that is what we are looking for. So both statements are correct and 2 is correct explanation. So option B is correct for this question. Now question number 25. Okay, we have 2 more questions. Both are statement based question. In a compound microscope, the focal length of objective lens is large, whereas focal length of eyepiece is small. Statement 2, the magnification of compound microscope varies inversely to the focal length of both objective lens and eye lens. Okay. Let's see question number 25. Who will answer? Komal Rukmini Nagraj is saying option D. Statement 1 is wrong, but statement 2 is correct. Yes, we know that magnification is given by L by FO into D by FE. Right? We try to keep both focal lengths as small as possible in compound microscope. So the first objective focal length is large, whereas eyepiece is small. That does not make any sense. Okay, both focal lengths we try to keep it as small as possible, and second statement is correct definitely. For infinite case where the image is formed at infinity, we do see the magnification given by this formula, where magnification is directly proportional, inversely proportional to FO and FE. So statement 1 is wrong, statement 2 is correct. Last question. In refracting telescope, the focal length, now we are going back to telescope. In refracting telescope, the focal length of objective lens is large, whereas focal length of the eyepiece is small. The magnification of refracting telescope directly proportional to focal length of objective lens and varies inversely with the focal length of eyepiece. Let's see. 26 saying A. Statement 1 and 2 both are correct statement, and 2 is a correct explanation. So in this case, magnification is given by FO by FE. Okay, definitely this is the correct statement, and because of this we can say that magnification is directly proportional to FO and inversely proportional to FE. So definitely in this particular case both are correct and statement is correct explanation. So definitely this is the correct answer. Sir, where can I get ray optic one shot? NPN Gamer ray optics one shot is for Brahmastra series. It is already there. You can check that. All the important questions I have discussed. Chapter wise ray optics one shot is there in the last year in KCET. We did one series called Master Stroke. You can go and check that out. There I have done ray optics Master Stroke. If you search in our channel, you should get that video of theory. Rukmini is saying, can you explain 22? Okay, Rukmini, why not? Focal length of equiconvex lens of refractive index 1.5 placed in air is equal to radius of curvature of either face, any one of the faces. Okay, so you can use the lens maker's equation. Okay, let me start from scratch so that you can understand. Let me erase it. So we know that from lens maker's equation, what is lens maker's equation? 1 by f equals to n minus 1 by r1 minus 1 by r2. This is the formula. Now if it is not an equiconvex lens, then r1 is not equals to r2. Right, but in case of equiconvex lens, R1 is actually equals to minus of R2. Okay, why minus? So this is a lens. Okay, this side is R1. This is falling along the positive x-axis. So this is positive, and this is R2. This is R2 means this is along the negative x-axis. So negative x-axis means R2 is negative. Clear sign convention. If you had any doubt related to sign convention, then this should be clear your doubt. Now R1 equals to R2, and we say this is equals to a common value R. So if you put these values back into this equation, what you will get? You will get n minus 1 by R minus 1 by minus R. Okay, so you will get n minus 1 into 2 by R. Right, this is the formula for any lens, any equiconvex lens. Okay, any equiconvex lens you can use the formula. For any equiconcave lens, you have to add a negative sign. Both will be negative, negative sign will be common, so negative you have to take common. Other than that, formula will be same. Now if you put n equals to 1.5, if you put n equals to 1.5 in this equation, you will get this as 0.5. 1.5 minus 1 is 0.5 into 2 by r, that is 1 by r. That is f equals to r. Right? So first statement where it is says that the focal length of equiconvex lens of refractive index 1.5 in air is equal to radius of curvature of either face. So this is the statement, f is equals to r. Now which r you will take? Both are same, right? Magnitude wise both are same, so any one of the r is answer, right? Now why this is possible? This is only possible because of this. Okay, if this statement is not true, then this would not be possible to get f equals to r, right? Because then 2 by r was not possible. 2 by r was not possible means 0.5 into 2 would not give you 1 by r, right? So that means this is only possible because of r1 is actually equals to minus r2 equals to r. So both radius of curvature are equal. That's why this is possible. So this is the statement, this is the reason. So statement 1 and 2 both are correct, and statement 2 is the correct explanation. So that's why option B is correct, right, Rukmini? I hope your doubt is cleared. So if you have any more doubts, please start asking. Our all questions are cleared for the day. 26 questions we have solved, and today we have solved in record time. Okay, within 50 minutes we have completed all the questions. Congratulations. Okay. And congratulations to all those who joined in today's live. Right? So if you have any other doubt related to this chapter, then please don't forget to mention that in the comment below. Bye Nagaraj. I will also like to end this lecture. So if you have any other doubts, any more questions related to any other topics, any other subjects, please mention in the comment section below. I will try to answer that as much as possible. Right? We'll see you in a new video very soon. Till then, bye.